You guys ready?
Thank you.
You're welcome. Here we go. Number 1 from the digital practice test. Slow down, okay? Slow motion. What am I solving for here?
X.
Good. I'm solving for the value of x, okay? Pencil in hand, Ricky, okay? Even if you already took notes in class, you take them again because that's why we're here. We might as well use the time to just really review. So we're solving for the value of x, but x is in 2 places. So what do we do? Combine like terms. And if you know me by now, what do I do before I try to combine like terms? Circle your terms with their signs. So I'm going to circle my 7x, my positive 3, and my negative 4x. We know that if a term does not have a sign in front of it, what is the sign? Positive, okay? So usually our first term, if it's not negative, it will have a invisible positive sign. Okay, so what terms can be combined?
7x and negative 4.
Very good, our x terms. 7 plus negative 4 is?
3.
3 is correct. So should I just put 3 or is it 3x?
3x.
Good. Now I'm done with this and I'm done with this. I cross them out so that I don't get them confused and try to use them again, okay? So I have my 3x's done and I have my positive 3 over here. It doesn't matter if you put 3 plus, if you wrote 3 plus 3x, that's the same thing, commutative property of addition. So it doesn't matter which one you put first as long as your signs are correct. Okay, we're gonna set that equal to 12, just like it says. Then we're gonna solve for x, but it's much easier now because x is only in one spot. Aubrey, how do I solve? What do I do here? Good, subtract 3 from both sides. My marker's running out, so that was going in the garbage. That did not work. And my positive 3 and my negative 3 cancel out to 0. So that can disappear because 3x plus 0 is just 3x. So now I can simplify here, and I have 12 minus 3 is? 9 equals 3x. And then, Melanie, what do I do as my last step? Divide by? Hold up. I'm asking Melanie. I really want her to help me. What's that? Divide by 3. That's really important because we're trying to get x by itself. What's happening to x is it's being multiplied by 3. We have to undo that. Do the opposite operation. If it's being multiplied, divide by 3. That allows us to cancel out because 3 divided by 3 is 1. And 1x is simply x. Good. So now when we divide on the other side by 3, we get 9 divided by 3 is 3. So 3 equals x, and that is our answer for x. When you are taking your test, what would be a really good idea to double check that this value is the correct value for x?
Wait, you can check. Wait.
You just plug it in. Plug it in and make sure it works. So if we want to plug in x equals 3, let's go ahead and substitute 3 for each x value. 12 equals 7 times 3 plus 3 minus 4 times 3. And let's just double check that this is a true equation. So we order of operations, we go PEMDAS, right? We don't go SATMAP, we go in order because we are solving just a regular equation, we're not undoing everything. So we're gonna do our multiplication first. We have 7 times 3 is? 7 times 3 is? 21, that's done. Now we're gonna skip the addition. We have a negative 4 times 3 is what?
12.
Negative 12, so that cancels that out. And then I have a plus 3. We want to make sure that equals 12. Now we're going to solve, we only have addition and subtraction, so we solve addition and subtraction from left to right. It doesn't matter if addition comes first or subtraction, as long as we're solving left to right, like reading a book. 21 plus 3,
24.
24 minus 12 is 12. So this equation is true. That means 3 is the correct value for x. So do you guys see how you can actually check to make sure you got your answer right before you even submit your test? Now, you have to be really careful when you're checking your answer. If you don't do order of operations correctly, you will not get the right answer, and you'll think that your x answer is wrong, so you have to follow your order of operations.
Miss Slay,
Yeah?
when, you know how it, like, automatically submitted it?
Yeah.
If I, like, go to a different problem and then go back to the other problem, it, like, changes.
Yeah, it will change every time. But I'm not grading that, so I don't care what your score says, even if it says 0 because you submitted on accident. It's just for review, so don't even worry about it. All I want you to do is make sure you are paying close attention. Do you guys want to go over this in detail?
Yes.
Okay, yeah. You have a question on that? Can you skip it and I'll come back to you? Because I think Jared will be back down really soon, okay? So, I mean, I hope so.
I heard him laughing.
Okay, outside the door? Okay, so maybe he's coming back. Okay, so what is the first thing we're gonna do here? Distribute.
Oh, yeah.
We're just going to simplify, and the first way we can simplify, at least on this side of the equation, is to distribute. So we have 5 times 3x equals 15x. 5 times positive 6 is
30.
So, and it's positive 30, so we need to make sure we put positive 30, which also acts as an addition sign. But our positive and negative signs will give us our addition or subtraction signs if we do them correctly. So that's distributed. We're going to leave that as is for now. And then we're looking at our other side, and we have a negative 26 plus
They're like terms.
41. They are like terms, they're just numbers. So let's do something really cool. We're going to circle each term with its sign and combine them. So I'm adding a negative 26 and a positive 41
It's 15.
is positive 15. Good. Now, Melanie, sorry, I'm going to pick on you a little bit today because I want to make sure you are ready for this quarterly, okay? Melanie, what is the next thing that I do here to solve for x? You don't know? Can I give you a hint? Would you like a hint? So x is all caught up in 2 operations. Can you tell me one of the operations that you see? Operations are multiplication, division, addition, subtraction, technically exponents and roots, but we're not dealing with those. So out of those 4 that I mentioned, multiplication, division, addition, subtraction, which 2 operations do you see that x is involved with on this side of the equal sign? Addition and multiplication. So if we have addition and multiplication, since we're solving algebraically, meaning we are undoing what is happening to x, what does that mean for our order of operations? Hold on. In general, not just for this, what does that mean for order of operations? Does order of operations mean we have to go in a specific order?
No.
That's exactly what order of operations means. Order of operations means your operations have to go in the correct order to get the correct answer. We know order of operations as an acronym called, starts with a P?
Parentheses.
Nope. An acronym, which is like each letter, yes, thank you, PEMDAS. Each letter of the word stands for something. Parentheses, exponents, which we're not dealing with right now. Multiplication, division, addition, subtraction. These are the same step. These are the same step. This one comes first. This one comes second, from left to right, but we're solving algebraically. We are undoing what has been done. If we're undoing something, we need to go backwards order of operations. So instead of taking care of the multiplication first, we need to take care of the addition and subtraction first, okay? So this is the regular order of operations. SADMAP, which is me just writing it back, PEMDAS backwards, is when you're solving algebraically. So this would be first, and this would be second, okay? So we're going to solve our addition or subtraction first. Or I should say we undo that first. So Melanie, what should I do if I have to take care of the addition subtraction step first? Well, what is being added? Let her do it on her own. It's totally fine that we're going slow. When people are watching this video, they're going to be very thankful that we're moving slowly. Do you know, can you see something that's being added? The 30 is being added. So how can we undo that? We undo it by doing the opposite to it. What's the opposite of adding it? Subtracting it. And that's how I get minus 30. The reason I want to do that is because it cancels it out, it erases this and makes it simpler. To keep this equal sign true, what do I have to do on the other side? Good, subtract 30. To keep the equal sign true, we have to do the exact same thing to both sides. Now I have 15x is by itself, so it's getting simpler, and then I have 15 minus 30, which is negative 15. Now, x is still not by itself, but it's much closer. We're halfway there. Melanie, what is happening to x right now? What operation? What operation do you see that x is involved with here? When 15 is next to x, do you know what operation that is? What's that? Multiplication. Here. You need some sugar encouragement. You do? Find it right on your shoulder. Okay. No.
What if I finish?
Maybe. All right. We see that multiplication is happening here. Melanie, what is the operation that will undo multiplication? What is the opposite of multiplying something? Yeah, dividing it. So we're going to take x times 15. We're going to divide it by 15. The 15 over 15 equals what? 1. That's how it cancels, because 1x is simply x, right? 1x, 1 times x is x 1 time, so it's just x, right? Notice how in algebra, when we cancel things, sometimes they cancel to 0, and sometimes they cancel to 1. It just depends on which operation we're doing. 0, if you're adding and subtracting, that's what's going to wipe it away. If you're multiplying and dividing, canceling it out to 1 is what wipes it away, okay? So we do the same exact thing to the other side. We get x equals, what? Good, negative 1. And that's how you get your answer. And I won't do this because I don't want to take up too much time. Yeah? You do need help? Okay, I'll be right there. Can you move on to like all the ones, and then at the end when I'll turn off the video and I will just help you. Okay. So we have x equals negative 1, and that is our final answer. When you're taking your test, you can absolutely check by plugging it back in. Okay, so this is.
Isn't this kind of like a backwards?
This is pretty much the same thing. We just have to be extra careful with our negative number that's being distributed. So, when we distribute, what number are we distributing?
The number that's not in the parentheses.
Yeah, just tell me.
-4.
-4. We want to say -4, not just 4, okay? Sometimes, actually, it might be a good idea to circle it so we remember that that negative number is being multiplied. Hands up for a second. Hands up real quick. Gotta do a check.
I'm pulling out all my laptops.
Right, because I said hands up and you knew I was coming back there.
And all I have is news.
Nope. That's all I needed to see. Okay, I didn't even need to come over to see that you had a tab open. That was not what you should have been working on, correct? Okay, so what are you on now? Are you on this? Okay, we're gonna stay on this. Because next time I say hands up, if I see your hand go down while I'm walking over there, I'm gonna know again that you had a tab open that you shouldn't have open, okay? This is review for the quarterly final. We need to stay on task, okay? We are distributing the -4 to each of these terms. You might even want to circle this -7 to remember that we're multiplying a -4 times a positive 5x, then a -4 times a -7. This is where I see a lot of mistakes because you guys aren't paying close attention to those negatives and positives. You should have a notebook open and taking notes. So, we can even start over here because we can simplify our numbers here. They're like terms. They don't need to have a variable to be like terms, right? 16 plus 12 is? 20 equals, then we have -4 times 5x equals?
24. -20.
-20x. Then I have -4 times -7 is? Positive 28. Good. From here, Aubrey, how do I solve this for x? Just Aubrey. Add 20? Okay. First, what? Okay, so I'm gonna show you what happens if I add 20, okay? If I try to add 20, I'm not gonna be able to cancel out my -20x and my 20 because they're not like terms, I can't combine them. So all I have is a -20x plus 20, I can't do anything with that. X is being multiplied by -20. So adding 20 isn't going to cancel it. Do you understand? Remember, we have to do the opposite operation, which would be division, right? But we can't do it yet because we have the other operation that's happening that needs to be taken care of first because we're going backwards. Okay, so what do we do? Good, subtract 28 from both sides. Now this cancels out to 0, and that's what we want because a -20x plus 0 or minus 0 is -20x, right? So over here we have 28 minus 28. Doesn't that look like it's going to cancel out also? Uh-oh. So do I write nothing here?
No.
Kind of. I write nothing but with a number. How do you write nothing with a number? 0. 28 minus 28 is 0. You know how when we cancel that out, we don't need to show the 0, right? When we cancel this out, we definitely need to show the 0 because it's the only value on this side of the equal sign. If you don't write anything, you're going to have this equals blank, and that's not going to make any sense. So we have 0 equals -20x. Divide by -20 on both sides. Exactly. 0 divided by anything except for 0. But don't worry about that. 0 divided by anything except for 0 is 0. So 0, and this cancels out to 1, 0 equals 1x, which is just x. So x equals 0. And it'd be really fun to plug that back in, because that'll be really easy to solve. So I'm making sure that you're
Okay.
right on that one. Yes,
Can I ask a question?
yes. Am I recording? I just want to make sure I actually hit the record button. Okay, good. Oh my gosh, that scared me. I thought I forgot to press it. Okay. This one's different because we have an x term on this side of the equal sign and an x term on this side of the equal sign. Uh-oh. We have to do something a little bit different for that. But before we take care of that, we need to combine like terms. Now, don't get confused here. These are like terms, but we can't combine them to 8x because which team would they go on? Which team would that 8x go on? It wouldn't be even. It wouldn't keep the teams balanced. So we can't combine those, can't do anything with those yet. But we can recognize that we have two numbers over here that when I circle them with their signs, I can combine them. So I'm just going to rewrite everything. 5x plus 7 equals negative 3 plus 20 is 17. Positive 17 plus my 3x right here. So I've taken care of those, simplified it, but I still have more to do. There are two things I need to do, and it doesn't matter what order you do them in. I've got these terms that are like terms. I've got these terms that are like terms. I have to take care of both of those, but I can't just put them together because there's no space for them. They're on opposite sides, yeah.
Couldn't you subtract 3x from both sides?
Exactly. Subtract 3x from both sides, and that allows us to remove the x term from there and keep our x term just on one side. But we're doing it in a way that keeps the equal sign true. As long as you're doing the same thing to both sides, everything's true, everything's good. Bring your face forward, please. 5x minus 3x is 2x, and I have my plus 7 equals 17. Now we just have a really simple solve for x equation here. Melanie, what do I do first? I just want to give you some more practice with this. Sorry, I know it feels like I'm picking on you, but I want to help you. What is my first step to solving for x? There are two things I need to do. What do I do first? What's that? Yeah, subtract 7 from both sides. 2x equals 10. And then what, Melanie? Divide by 2 on both sides, and I get x equals 5. You can plug that back in, make sure everything's right. That's it.
I need help on 3 problems.
Okay, and you're totally done otherwise?
I'm finishing 3.
Okay. I promise I will get to those problems. Let me just do a few more with them, and I'll make sure I devote my last 10 minutes to you, okay? All right, I'm gonna go ahead and skip this one because this is exactly like the one that we just did. All it is that it's a Q instead of an X. So we're gonna skip that one, but don't worry, I do go over it in detail in regular class. I'm just skipping the extremely detailed version here. Oh, okay.
Yeah.
This one and the next one are what some of you guys think are the hardest ones. And I'm not saying that they're easy. I'm just saying that, isn't it great when we don't have to do any actual math with numbers? It's great. Because we're not actually looking for a number value.
It's just rewriting.
We're just rewriting the equation, keeping the equal sign true, and using our algebra. Now the instructions might throw you for a loop. Let's read them. Solve the equation. Solve it. Does that mean I have to get a number? Nope. Solve it for the indicated variable. The indicated variable means the variable that they mention that they want you to solve it for. So it says solve the equation. The equation is this. The indicated variable is h, meaning solve for h. Solve for the indicated variable means solve for h, or whatever on your test, whatever this variable is, solve for that variable. Now we need this equation, a equals bh. We don't want it to be solved for a, we want it to be solved for h. All we have to do is use algebra to rearrange and undo what's happening.
Do we divide b on both sides?
Divide by b on both sides. H is being multiplied by b. We want the b to go away. The only way to make the b go away is to do the opposite operation, divide by b, on both sides. B over b cancels out to 1. It's just like putting 5 over 5, or 10 over 10, or -2 over -2, or 3.1 over 3.1, or a over a, or x over x, or shoe over shoe. Everything over itself, or Ricky over Ricky. If I put Ricky over Ricky, it's 1. And then he cancels out. I would never want to do that to you, Ricky. So it's a good thing we're just canceling out the b right here, right? B over b cancels out. Now I literally have my answer. H is by itself equals a over b. Make sure when you enter your answers, you are keeping your capital letters capital and your lowercase letter lowercase. Because your digital computer does care about that, because they do have significance in representing, like for example, capital A means area, lowercase b is base, and they want to keep it consistent. So, H equals capital A over lowercase b. That's it. Totally clear?
Finish all of them.
Okay, good. I'll be with you in just a minute. It's just I can't stop the video and then restart it, so I'm just gonna do a few more of these, and then I'll let them continue working, and then I will help you in just a minute. Okay, so this one is a little bit trickier because there are 2 steps to solving it, but it's literally just like the ones that we were doing when we were solving for x. Remember that let's say I had like 6 equals 5x minus 2, okay? You guys knew what to do. You just added 2 to both sides and then divided by 5. This is the same thing. Oh, you know what, yeah, I'll say it's the same thing, okay? This one's solving for d. This time it says solve the equation for the specified variable. Same thing as indicated variable. Before they indicated it, like hinted at what variable by just writing h. Now they're specifying the variable, being very specific and saying solve for d, which means get d by itself. Good, alone. Isolate it, get it by itself. Put it in the corner and say, you're alone and everyone else is on the other side of the equal sign. It's actually very sad, okay? So d has to get by itself. We have y equals d times a, and then that product is being subtracted by 2. So there are 2 operations, multiplication and subtraction. Are we going backwards to solve this? Yes, we are undoing it. So we have to go backwards order of operations. Which one do I take care of first? The multiplication part or the subtraction? The subtraction. In regular order of operations, PEMDAS, we would handle multiplication first. But that's if we actually have numbers to multiply, right? But we're going backwards, we're undoing it. So we have to flip it. And we say, well, first I have to take care of this -2 or the -2, then I'll take care of the multiplication. So we're gonna add 2 to both sides. A -2 and a +2 cancels out to
1.
0. -2, what?
You even said 1.
Yes, and I also said just a minute ago that when you cancel out addition subtraction, it cancels to 0. When you cancel out by dividing or multiplying by a reciprocal, it cancels to 1. Do you understand? Because we want to cancel this out to 0, so we can say dA plus 0. That's just dA. And when we cancel out to like 1x, that's just x. That's how we cancel it out. So that cancels out to 0, it's gone. This, y plus 2, how do I write y plus 2? Can I combine them? Can I combine it to 2y? No, they're totally different terms. This is a y term, this is not a y term. So the way that I write y plus 2 is y plus 2 equals dA. That was step 1. Doing the opposite of the subtraction to both sides, rewriting it in like the horizontal form, right? Because that's how we write our equations. Now we have one more thing to take care of. Which variable are we solving for, Ricky? Good, we're solving for D. So what do I have to do, Abby?
Divide
By,
A.
very good. We're gonna divide by A on both sides. It's gonna look a little different on this side. I'm dividing both sides by A. This entire side needs to be divided by A. The A over the A cancel out to 1, because 1D is just D, it's a D.
Oh, so the y plus 2 is over A.
Yes, the entire expression y plus 2 has to be over A. So when you type it in digitally, it smells so good in here right now. I don't know what they're cooking, but it smells really good. Okay, the whole expression y plus 2 has to go in the numerator, and then the fraction bar, A, underneath, okay? When you type it in digitally. Are we good? As soon as Zach gets back from the bathroom, I'm gonna switch over to help him with his geometry. But for now, let's try to do one more slow down. Okay, solve the following inequality. Instead of calling this an equation, it's called an inequality because we're dealing with a set of numbers as a solution for x. So it's not just gonna be like x is 2, x is negative 5. It's gonna be x is anything that's less than something. So it's gonna be a wide range of numbers, but it's gonna be a specific set of numbers. But we treat it just like an equal sign. Only time we have to pay close attention to the fact that it's actually an inequality is if we're dividing by a negative, because then we have to do flippies, switchies, whatever, yes, switchies, I don't know, flippies or switchies, they flip the sign, whatever. Okay, so, but we're gonna treat it like an equal sign for now. So what do? This is my last one, Zach, and I'm helping you, okay? What do we do to solve for x? Yes?
Subtract 1 on both sides.
Good. That cancels to 0. X is less than,
Negative 8.
and that is how simple that problem is. You don't have to do anything else. Now, when it says the solution is, if you write negative 8, it will mark it wrong. You must say x is less than negative 8, and it gives you that instruction right here. It says type an inequality. It doesn't say just put negative 8. It doesn't say type an integer. It says type an inequality. You need to write x is less than negative 8. Because if you say the solution is negative 8, you're saying that x equals negative 8. And that's not true. X can be anything less than negative 8. For example, negative 20, negative 9, negative 10.32. Okay? So the solution is any x value that is less than, any number that is less than negative 8. And that's it for this portion. You guys can continue
Don't
to,
have to flip it.
only if you're dividing by a negative. We just subtracted 12. Remember we talked about that yesterday?
I know.
I know, you gotta stop flipping things that don't need to be flipped, girl. All right.